Okay, so what we want to look at here is the position vector and the displacement vector. So what I want to do is set up our coordinate system again, which again is the Cartesian coordinate system. So I'm going to draw my three axes. So here we have x, y, and z. And what we want to do is to specify a vector from the origin to some point at x, y, z. And this vector from the origin to that point is called the position vector, given by r. So our position vector r will be equal to x hat plus y hat plus z hat. This position vector r is going to have a magnitude, and the magnitude of the position vector r is going to be given by the square root of the sum of the square of the component. So it's going to be x squared plus y squared plus z squared. So this magnitude of r is the distance from the origin to that point P. We can also specify a unit vector, which is going to be given by r hat. And r hat is simply written as our vector r, our position vector r, divided by the magnitude of this vector. So that is equal to x hat plus y hat plus z hat divided by the square root of x squared plus y squared plus z squared. And this unit vector r points radially outwards. Now, let's suppose that we move this point P by a very, very small amount. Okay, so we just displace it from x to x plus dx. Y goes to y plus dy, and z goes to z plus dz. Now what we can write down here is an infinitesimal displacement vector from the point x, y, z to the point given by y plus dy, x plus dy, and z plus dy. So our infinitesimal displacement vector then is dl be equal to dx x hat plus dy y hat plus dz z hat. Now it's important to take note of this because this infinitesimal displacement vector is going to come up time and time again throughout this course.